Same deal here. We look at this. Okay, well, if we let h equal 0, well, that's going to be 2 to the negative 1 minus 2 to the negative 1, which is 0 over 0. So we rewrite this as the limit as h approaches 0. We recognize this is a complex fraction. And complex fractions are not going to go away. You find the LCD for the top and the bottom is combined. What's the first fraction missing? A 2. The second, 2 plus h. And if you have the top and the denominator having the same LCD, you ignore the denominators of both fractions and you convert that into a single fraction. You read the top, 2 times 1 is 2, minus 2, minus h, and the denominator, no need to multiply this because you need to get rid of that 0, which is the h. So this is the difference quotient formula that you've seen back in the days. So cancel those. I'm looking at the limit as h approaches 0 of negative h over 2h into 2 plus h. Cancel the 2's. Limit as h approaches 0, negative 1 over 2 into 2 plus h. Now that I canceled a factor, which is 0 over 0, I throw the h equals 0 in. I'll get negative 1 over 2 into 2 plus 0, which is 2, and that's a negative 1/4. So on your test, when I say evaluate the limit, you could do it any way you want. When I say find the limit, a calculator will not be accepted. That's all of these problems. And we're going to do another problem like this because those, again, they arise a lot more than you like. And we would, let me see, can I put some space? It's too close. Okay, that's better. Same deal, we had h equals 0. We get 1 over x minus 1 over x, which is 0 over 0. Same deal. They're the same type of problems. This would be an LCD will be x into x plus h. What's this missing? An x, top and bottom. Just read the top. This is missing an x plus h if you multiply top and bottom. And the denominator is missing both. So that's going to be h times x into x plus h. So once you get the hang of this, that's really how it works. X, distribute the negative n, minus x minus h over hx into x plus h. Limit as h approaches 0 of negative h over hx into x plus h. Once you cancel out a factor, you restart the rule of thumb, plug h equals 0 in, and that gives me a negative 1 over x times x, or negative 1 over x squared. So that's something that we're going to do for some time. Make sure you are comfortable with rational functions. You get around it by factoring. Radicals you multiply by the conjugate, and complex fractions. Now, sometimes there's a function you can't seem to control. But you know this function is between two other functions. If I take the limit of the smaller function as x approaches a value, say a, and I get a number, and I take what's larger and I get the same value. So if the above and the below are approaching a value, whatever is in between is going to be forced to reach that same value. That's called the squeeze theorem. If you took AP Calculus in high school, that's called the sandwich theorem. Same thing. So whenever you quote it, ST will do, and it works on both ends. So this problem right here is very hard to show. Instead, what we do, we say, well, what? Okay, sine and cosine specifically. Those two, we know for sure. So we can't take that limit because 1 over 0 is undefined. So what we say look at x squared cosine of 1 over x. What's the biggest this cosine could ever be? Isn't that a 1? What's the smallest that cosine could ever be? So wouldn't you say x squared, the cosine of 1 over x, is between x squared and negative x squared? Now if I take the limit as x approaches 0 of negative x squared, plug that in, isn't that a 0? Negative 0 squared is 0. And if I take the limit as x approaches 0 of x squared, that's 0 squared, which is 0. Therefore, the limit as x approaches 0 of what's in between, even though it's undefined, equals 0 by the squeeze theorem or the Sanders theorem, however you want to quote it. Alright, a couple more to go. Absolute value is a bit tricky. Well, let's make sure we get that. Find the limit if it exists. If the limit does not exist, explain why. Alright, so absolute value, remember, absolute value of A, if the inside is positive or 0, then I don't need an absolute value. If the inside is negative, I will take whatever is inside the absolute value and multiply it by minus. I'm taking the limit as x approaches negative 1. If I take the limit as x approaches, negative 3 from the left, let's say 2.9, negative 3. From the next, say negative 3.01. If I put negative 3.01 plus 3, isn't that negative? That indicates that this quantity is negative. So it's this case. To drop the absolute value, I put a minus in front of it. The top, I'll factor a 2 out. And I notice those cancel out. And that will be the limit as x approaches negative 3 from the left of negative 2. And the limit of a constant is the constant. Very good. Now if I take the limit as x approaches negative 3 from the right, let's say 2.99. Negative. Negative 2.99 plus 3 is positive. If it's positive, I don't need the absolute value. So I just drop the absolute value. Factor a 2 out of the top. That's the limit as x approaches negative 3 from the right of 2. The limit of the constant is the constant. But what do you conclude? I took the limit from the left, I got it to be negative 2. The limit from the right, I got it to be 2. Therefore, the limit as x approaches negative 3 of 2x plus 6 over x plus 3 does not exist. And if they say justify your answer, you say because the limit from the left does not equal the limit from the right. Another problem we have, I want to take the limit as x approaches negative 1. Well, let's see. If I put a negative 1. Now, by the way, how come I didn't substitute that in? Because absolute value was not one of those four functions that I could use this rule of thumb on. I could use the rule of thumb on rational, which is polynomials divided by polynomials, a polynomial, a radical, and a trig, wherever they're defined. I can't use it on absolute value. Absolute value is not one of those shortcuts. So, I'll take the limit as x approaches negative 1 from the left. All what I want to do is get rid of the absolute value. This way, I will get it to be a rational, and I could play with it or manipulate it any way I like. Limit from the left. Let's say negative 1.01. Wouldn't that be negative for sure? If it's negative, I'll put a negative in front of whatever was inside the absolute value. That's the limit as x approaches negative 1 from the left. That becomes a plus. That is the limit as x approaches negative 1 from the left of 1, which is 1. Now I take the limit as x approaches negative 1 from the right. From the right, let's say negative 0.99. If I put in a negative 0.99, isn't that negative? I still have to put a minus in front of whatever was inside the absolute value. And I know the drill. So what's the conclusion? Therefore, the limit as x approaches negative 1 of 1 minus absolute value of x over x plus 1 equals a 1. How come it worked for this but it didn't work for the previous? Because they're not taking the limit as the cutoff of the absolute value. This absolute value changes signs at 0, not at negative 1. At negative 1, it's always negative. How about this problem? I want to take a single-sided limit. Well, that's the limit as x approaches 0 from the right, 1 over 2x you can't touch. What is the limit as x approaches 0 from the right? If I pick 0.1, well, doesn't that make this positive, so I don't need the absolute value? Now, the limit as x approaches 0 from the right, a quantity minus itself is 0. What's the limit of a constant? Isn't that the constant? Done deal. How come I didn't substitute the 0 in? I can't because of absolute value. How about this problem? Let g of x be x plus 3 if x is less than 2 and x plus 1 squared if x is greater than or equal to 2. Find the limit as x approaches 2. Take the limit as x approaches 2 from the left. Remember, this is 2 from the left. You're really using x plus 3. That's a polynomial. You plug the value in by the shortcut. If you plug the value in, that's 2 plus 3. That limit is a 5. How about the limit as x approaches 2 from the right? 2 from the right, you're bigger than 2. You're going to use x plus 1 squared. This is a polynomial. Throw the 2 in. That is 2 plus 1 squared. That is 9. Therefore, the limit as x approaches 2 of g of x does not exist. And if they say why, because the limit from the left does not equal the limit from the right. So whether you plug in numbers using the shortcut, it's the same analogy. And the last thing I want, this comes up on the homework, so I want to make sure that you see the graph. I'm not sure if you've seen that in your previous courses or not, but here it is. There are really 3 functions like that, but we only focus on one in this class. Sketch the graph of f of x equal greatest function less than or equal to x. Again, we're going to only go after the graph because there are homework problems on that, and it's going to come up with continuity the next section. So I need to make sure that you understand this. So this is how it works. X, a greatest integer less than or equal to x. And I put a number line. I'm going to pick 0. So if I pick a 0, what's the greatest integer less than or equal to 0? Well, 0. How about if I picked 0.5? What's the greatest integer less than or equal to 0.5? Wouldn't that be 0? How about if I picked 0.8? What is the greatest integer less than or equal to 0.8? That's 0. What if I picked 1? What is the greatest integer less than or equal to 1? Well, it's 1. It's not less than, but it's equal. What if I picked 1.1? What's the greatest integer less than or equal to 1.1? Well, obviously it's a 1. How about 1.5? What's the greatest integer less than or equal to 1.5? Well, that's 1. How about 1.99? The greatest integer less than or equal to 1.99 is 1. What if I picked 2? The greatest integer less than or equal to 2. Well, it's not less than, but it's equal to 2. Continuing that trend, what if I went for x equaling 2.2? What is the greatest integer less than or equal to 2.2? That's 2. How about 2.5? That's 2. 2.9, that's 2. How about 3? You jump at 3. So 0, 0, 0.50, 0.80. Isn't it any value between 0 and 1 will give me 0? What happened when I get to 1? I am at 1. 1.1, if x equal 1.1, y equal 1. 1.2, 1. 1.3. What happened when I get to 2? I jump to 2. And then I fill all of those. When I get to 3, I jump to 3. If I pick negatives, it works out the same way. And hence, this is what's known as the famous step function. So you need something like that for the homework, and continue with the next section. And that's pretty much it for this section.